Hello students, I am Sachitrakar. Welcome to Cars Physics. We are continuing projectile motion. Okay, so we have discussed two lectures on projectile. In first lecture we have discussed a body projected from horizontal surface making an angle. Means the velocity with which the body is projected makes some angle with horizontal or with vertical. Okay, and in lecture number 2 we have discussed a projectile from from a height, and under this means projectile from a height we have discussed 3 cases, and I hope you have enjoyed the lectures. And in this lecture we will discuss projectile from an inclined plane. So a body is projected on the surface of an inclined plane. Okay. So before going to discussion, let's recap about the first lecture. Okay. That will be useful. A body. This is a horizontal surface. A body is projected with velocity u making an angle theta. So as you know, this is taken along x-axis and perpendicular to x-axis, that is y-axis. So this velocity makes an angle theta with x-axis. So initial velocity in x direction is u cos theta, and initial velocity in y direction uy is equal to u sin theta. And we know acceleration due to gravity acts in vertically downward direction, which retards u sin theta. Okay, u sin theta and acceleration are in opposite direction, but acceleration due to gravity has no component along horizontal, means along x-axis. So this velocity remains constant since acceleration is 0 in x direction. So this is acceleration in x direction, this is acceleration in y direction. Acceleration in y direction is g, which is opposite to u sin theta, and as we have discussed, if a body is projected from horizontal surface making an angle, then it moves under combined effect of constant horizontal velocity and decreasing velocity in vertical upward direction till it reaches the highest position. This is maximum height reached by the body. So u sin theta is responsible to move the body in upward direction, and this is highest position. Thus at highest position u sin theta becomes 0, then only velocity is at highest position, that is u cos theta, and again initial velocity in vertical direction is 0, but there is acceleration due to gravity. So after reaching highest position, the body moves under combined effect of constant horizontal velocity and increasing velocity in vertically downward direction due to effect of gravity. Means vertical velocity first decreases, becomes 0 at highest position, thereafter increases. Okay. And finally the body strikes on the surface. Okay. This is velocity of striking, final velocity. This is Vx and this is Vy. Okay. You may take this angle alpha, but if air resistance is neglected, angle of projection is equal to angle of striking. Okay. If air resistance is neglected, then time of ascent is equal to time of descent. Okay. So in this case we have got, this is x direction, time of flight, the body is projected at t is equal to 0 and body strikes again the horizontal surface when time is t. Then t is time of flight, as we have got t is equal to 2 u sin theta by g, and maximum height we have got u square sine square theta divided by g, and horizontal range means maximum horizontal distance traveled by the body during time of flight. This distance is horizontal distance, means range, as we have derived, range is equal to u square sine 2 theta divided by g, and r is maximum when theta is 45 degree. So maximum range is equal to u square by g. Similarly, height is maximum when or if range maximum if theta is 45, height maximum if theta is 90 degree, sin theta must be maximum. So maximum height is u square by, sorry, this is 2g, u square by 2g. Okay, so these are our output, and of course we have derived the expression for instantaneous velocity. We have discussed all these in brief. Okay, so in this lecture we will discuss a projectile from the surface of an inclined plane. So you just think, this is an inclined plane. This is an inclined plane. So our discussion is projectile on an inclined surface or inclined plane. Okay. So this is horizontal surface. This is horizontal surface, and this is inclined plane or inclined surface, and angle of inclination is theta. Okay. So in first case we will consider a body is projected on an inclined plane in upward direction. Okay, we will see. Direction of acceleration due to gravity is in vertically downward direction. And this line is perpendicular to inclined plane. Okay, so this angle is theta. Component of acceleration due to gravity is g cos theta, which is perpendicular to plane. Let's take this is alpha. Okay, because angle of projection we have already taken theta. So this is angle of inclination. So this angle is alpha. This component is g cos alpha. G cos alpha is perpendicular to surface, and another rectangular component is g sin alpha, which is parallel to the surface but in downward direction. Okay, now of the plane, projectile on an inclined surface, we are considering first motion of the plane. Okay, but you see, this is x direction, this is y direction. We are considering motion on this surface means an inclined plane. Okay, see, this is inclined plane. This is horizontal surface. Angle of inclination is theta. Suppose a body is projected with a velocity u, making an angle theta with the inclined plane or inclined surface. So here theta is angle made by velocity with horizontal. Here theta is angle made by velocity with inclined plane. Okay, so obviously this component, now let's consider this is x direction, and perpendicular to x direction this is y direction. You may take x dash y dash. This is x axis, this is y axis. Let's consider this is x direction and this is y direction. So initial velocity in x direction we are taking x dash and y dash, So initial velocity in x direction is u cos theta, and initial velocity in y direction is u sin theta. And as we have discussed here, g cos alpha is perpendicular to surface but in downward direction. So this is u sin theta perpendicular to surface, because these are two rectangular components, u cos theta and u sin theta. So obviously this angle is 90 degree. So u sin theta here perpendicular to inclined plane, and g in downward direction, that is g cos alpha. So this motion is retarded initially till it reaches highest position, and u cos theta is in upward direction along the plane, but in downward direction parallel to the plane. Here acceleration in x direction, is equal to g sin theta alpha, and this is acceleration in y direction, that is equals to g cos alpha. So this is y direction, let's consider like this, and this is x direction. Just compare with the first. We have discussed this type of projectile which is fired from horizontal making an angle theta, and here fired from the inclined plane making an angle theta with incline. Okay. Now it may be made very easier if you compare with this projectile. This is x direction, we have taken this is x direction. Perpendicular to x direction is y direction, this is y direction. And if you again want explanation, x direction, y direction. In x direction, initial velocity is u cos theta. In x direction, acceleration ax dash is equal to g sin alpha, but g sin alpha is opposite, means ax dash is opposite to ux dash. So this is retardation, g sin alpha. Similarly, in y direction, initial velocity in y direction is u sin theta, and acceleration in y direction is minus g cos alpha, because g cos alpha is opposite to direction of u sin theta. Okay, again the similar thing here, acceleration is minus g. Okay, and this velocity remains constant, u cos theta remains constant, but here u cos theta decreases due to effect of this acceleration, means component of acceleration due to gravity, which is opposite to u cos theta. Now it is simpler. Then the body, as we have observed, moves like this and finally strikes on the surface. Okay. Then this is horizontal range, not horizontal here. This is an inclined plane. So maximum distance on incline means in x direction. Maximum distance is r, as we have taken here in x direction r. In x dash direction, this is also r, and this is height above the incline. So to take this height means perpendicular to incline, this velocity is responsible. So finally at the highest point u sin theta is 0. Okay, because y component is 0, because y component takes the body in upward direction. Okay, then what is in first bit? Number 1, time of flight t. See, body is projected from this position when time is 0, and body strikes the inclined surface when time is t. Okay, so we have taken this is y direction, y dash, and body starts from this position and strikes at this position. So what is displacement in time t in y direction? No displacement. Displacement is 0, because when the body starts from this position and reaches at this position, starts from surface of incline and strikes on surface of incline, so there is no displacement, resulting displacement in y direction in time t, means in total time. So here displacement in y direction is 0. Okay. Now let's take equation. S is equal to ut plus half at square. Simple. Then sy, displacement in y direction. This is y direction. Displacement in y direction is 0. Uy, y dash. This is acceleration. Uy dash is u sin theta into t plus half. Acceleration in y direction is minus g cos alpha into t square. So this minus comes to this position. Then g cos alpha divided by 2 into t square is equal to u sin theta into t. Bring this to left side. T square and t get cancelled. So time period is 2u sin theta divided by g cos alpha. I am writing here time period, time of flight 2u sin theta by g cos alpha. Okay, we have completed the derivation. This is your result. Then maximum height. Maximum height above the inclined plane h. Above the inclined plane, this is maximum height, and C, final velocity in y direction is 0 at highest position. Just use this equation. V is equal to y dash. V is equal to u plus, v square is equal to u square plus 2a s. Okay. So to get maximum height means final velocity in y direction at highest point is 0. So Vy dash is 0. 0 square is 0. Uy dash square. Uy dash is u sin theta. U square sin square theta plus 2. Acceleration in y direction is minus g cos alpha, and displacement is h. This is displacement in y direction. Sy dash. At highest point, displacement is h in y direction. So this is h. So 2g cos alpha into h is equal to u square sin square theta. This is minus. Bring to left side. Then maximum height is u square sin square theta divided by 2g cos alpha. So to have maximum height means to get condition, theta should be, sin theta should be maximum. So again, sin theta is 90 degrees. So maximum height will be u square by 2g cos alpha, since alpha is constant for a given inclined plane. Okay, this is generalized expression for maximum height. U square sin square theta divided by 2g cos alpha. Is it okay? Have I remembered this? Can I erase this now? All this can be clear from this diagram. Okay. Then range. Range means maximum distance in x direction. In this case, range. I am not writing horizontal. Maximum distance covered by the projectile in x direction, range. So the simplest way to get range. See, this is displacement along x direction. Displacement along x direction, let Sx dash is equal to Ux dash ut. Time is t. In this time t, the body has covered a distance r in x direction ut plus r. Acceleration in x direction into t square. S is equal to ut plus half at square. So displacement in x direction in time t is r, range. Initial velocity in x direction is u cos theta, and time is t. We have already calculated. So we derived the formula for time period, t plus half. Acceleration in x direction is opposite to u cos theta. We have taken this is minus g sin alpha into t square. So range, formula for range is u cos theta into t minus half g sine alpha into t square. Just use this kinematics equation and put value of t and you can calculate for range. This is easiest. This is easiest. Okay. So I am writing this formula. R is equal to u cos theta into t minus half g sine alpha into t square. The most simplest way here, alpha is angle of inclination and theta is angle of projection. Okay. Then if you need the derivation, means what will be the result for range, then we can derive the formula also. Let's derive. But I will advise you to keep it in your mind, just apply this formula and put value of t, theta, u, etc. You can get value of range. Yes, we can derive the expression. Maybe longer one, again I will show you the shortest way. Okay. Then range is equal to u cos theta into t. Formula for time period 2u sin theta divided by g cos alpha minus half g sin alpha into t square. T is 2u sin theta by g cos alpha. T square means 4u square sin square theta divided by g square cos square alpha. Okay, this sin alpha 4u square sin square theta divided by g square cos square alpha. Okay, then range is equal to 2u square by g, 2u into u square divided by g, then rest factor is cos theta sin theta divided by g cos alpha minus half g sin alpha into 4u square by g square. I may write 2u square by g, because here also we have written 2u square by g, 2u square by g, then rest factor is 2u square, means here 2 g square, g, this is g. So 2u square by g into 2 by g is equal to 4u square by g square into sin square theta divided by cos square alpha. Then range is equal to 2u square by g. This is sin theta. Here also this is sin square theta. Bring sin theta common, sin theta. Then inside bracket, sin theta we have taken common. Then cos theta divided by cos alpha, 2u square by g, g cos alpha. Oh no, this is only cos alpha. 2u square by g, this is only cos alpha. So cos theta divided by cos alpha, sin theta we have taken outside, minus half g sin alpha into this 2 by g, 2u square by g, we have brought it common, 2 by g into this is sin square theta is brought common, then this is sin theta divided by cos square alpha. Okay, then this g get cancelled. Fine. So it should be cancelled from very beginning, g and g. No need to write here. No need to write here. Okay. Again 2 get cancelled. No need to write 2. Okay. So this is sin alpha into sin theta by cos square alpha. 2 cancels, g cancels, 2u square by g, we have brought it common. Then it is 2u square by g sin theta, then r this cos square alpha, then LCM is cos square alpha, and here cos theta, cos alpha minus, which is sin theta, sin alpha, sin theta, sin alpha. Then final formula for range, 2u square by g sin theta whole into no into cos theta cos alpha minus sin theta sin alpha. This is cos theta plus alpha divided by cos square alpha. This is formula. And in simpler way, this is sin theta. Okay, sin theta. Sin theta. Okay. So, in general way, I am writing here the range is equal to 2u square divided by g into sin theta divided by cos square alpha into cos theta plus alpha. This is your formula for range. Do you want the easiest way how to get this formula directly? Okay. I am erasing this. See. The body is projected with velocity u and this is x-axis. Let distance covered on horizontal surface is x in time t. This is distance covered in inclined plane r, and in same time t distance covered in horizontal plane is x. Then what is component of u in horizontal direction? That is u cos theta plus alpha. The total angle is theta plus alpha. Component of u in horizontal direction is cos theta plus alpha, and as we know, in horizontal direction acceleration is 0, means there is no component of acceleration due to gravity in horizontal direction. So this velocity is constant. So range is equal to u cos x. X is horizontal distance. X is equal to u cos theta plus alpha into t. Then x is equal to u cos theta plus alpha. Then formula for time period. 2u sin theta by g cos alpha. I think this is written by mistake. This is cos alpha. This is cos alpha. This is how to match your answer. This is cos alpha. I think previously we were solving. There are some mistake. This is not cos square alpha, but cos alpha. Cos alpha. Time period. Let's derive this again. Time period. Vertical displacement y. U sin theta into t minus half g sin alpha. Sorry, g cos alpha into t square. So half g cos alpha t square is equal to u sin theta into t get cancelled. Then t is equal to 2u sin theta by g cos alpha. This is g cos alpha. Sorry, g cos alpha. So this is g cos alpha. I think in previous derivation we have made somewhere it is written cos square by mistake. Okay. This is correct. Okay. This is x formula. Sorry. Let's keep it. What we have got, this is right. This is x, but we need r. This is formula for r, range. You see, cos alpha is equal to, this is base, this is perpendicular, this is hypotenuse. Cos alpha is equal to x by r, and r is equal to x by cos alpha. Okay, this is correct. We have not done mistake. This is correct. Then range is equal to x by cos alpha. X we got u cos theta plus alpha into 2u sin theta divided by g cos alpha whole divided by cos alpha. Then you got the formula. This is same. 2u into u, 2u square by g, 2u square by g into sin theta divided by g you have taken already, g, cos alpha into cos alpha, sin theta divided by cos alpha into cos alpha, cos square alpha into cos theta plus alpha. Okay, this is correct. So this is the shortest way to get range, and I will advise you, don't try to remember this formula. So use this, it will be easier, or you may follow this way. If you don't want to use the equation, you follow this way. This will be in shortest time. Okay, this is formula for range. Okay, then as in previous case, means projectile fired from the ground at an angle theta, we have found condition for maximum range when angle of projection is 45 degrees. Here alpha is constant, angle of inclination, but we will find condition for maximum range, means we will find what should be the value of theta so as range is, so as to get maximum range. So condition for maximum range. See, let's first find dr by d theta. In differentiation of range with respect to angle of projection, dr by d theta. Then this is equals to d by d theta of range. In place of range, we can write 2u square by g sin theta divided by cos square alpha into cos theta plus alpha. But we know alpha is constant, means angle of inclination is constant, only we have to adjust value of theta. Then this is equals to 2u square divided by g cos square alpha, 2u g constant, again alpha is constant, so cos square alpha is constant. Then d by d theta, the rest factor is sin theta into cos theta plus alpha. Okay. Then this factor is constant. You may take this is k, any constant k. Then d by d theta of sin theta into cos theta plus alpha, apply product rule. This is x, this is y. Then differentiation, keep sin theta constant. Then differentiation of cos theta plus alpha, cos theta. Differentiation of cos theta is minus sin theta, here cos theta plus alpha, so minus sin theta plus alpha. Okay. Then d by d theta of theta plus alpha, d by d theta of theta is 1 plus d by d theta of alpha is 0 because alpha is constant. Okay. And similarly plus product rule, keep cos theta plus alpha constant, then d by d theta of sin theta is cos theta. Okay, fine. Then a constant, this is minus sin theta into sin theta plus alpha. Okay, this is 1 sin theta plus alpha plus cos theta into cos theta plus alpha. See, if R is maximum, writing here, if R is maximum, then maximum is constant, means dr by d theta is equal to 0 because it is constant. Maximum is constant, so dr by d theta is 0, so put here 0. Then 0 by constant is 0, 0 by constant is 0. Then we may write minus sin theta into sin 0 by k is 0. Bring this first. Cos theta into cos theta plus alpha minus sin theta into sin theta plus alpha is equal to 0 by k is 0. Then what it comes? What we get now? See, cos theta cos alpha minus sin theta sin alpha. Then this is cos theta plus alpha. Cos theta plus alpha is equal to 0. Then we may write it in very easier way. Cos 2 theta plus alpha is equal to 0 means cos pi by 2. Cos 90 is 0. Then 2 theta plus alpha is equal to pi by 2. And here you can get theta. 2 theta is equal to pi by 2 minus alpha. And angle of projection is pi by 4 minus alpha by 2. This is condition for maximum range. Theta is equal to pi by 4 minus angle of inclination alpha by 2. All these are very, very important. So, if you put here, means value of theta, if you put value of theta here, then what we will get? Maximum range. I am erasing this part. Is it clear to you? Okay. Then, what is formula for maximum range? If range is maximum, what is the formula? Put this value of theta here, cos theta plus alpha, and sin theta. In place of theta, just put pi by 4 minus alpha by 2. Here also pi by 4 minus alpha by 2. Then we will get maximum. Range maximum is u square divided by g into 1 plus sin alpha. This is maximum range. Okay, we have got the condition. Now I will erase it. Fine. Another condition. Okay. If alpha is 0 degree, suppose alpha is 0, see, alpha is angle of inclination. If alpha is 0, then this inclined plane will be horizontal. If alpha is 0, means this case will come. Okay, then we will get formula for range as you have got in this case. Formula for range, you will get this case if alpha is 0. If alpha is 0, you may put here alpha is 0, this is cos theta. Alpha is 0, cos 0 1, range 2u square by g into sin theta divided by cos square 0, alpha is 0, into cos theta plus 0. Then what do we get? R is equal to 2u square by g sin theta cos theta. Got your result? Then formula for range u square 2 sin theta cos theta is sin 2 theta divided by g. Okay. If alpha is 0, then inclined plane becomes horizontal. Then the body is projected at an angle theta with horizontal. Then this formula again returns. Okay. So up to this is motion up the plane. And similarly, we may discuss motion down the plane. This is motion up the plane. Number 2, motion down the plane. Just analyze, just you may put all these formula without deriving. In similar way, you can use this formula. This angle of inclination is alpha. Suppose a body is projected from this inclined plane making an angle theta. And velocity of projection is u and angle of inclination is theta. Here ux. In downward direction, that's equals to u cos theta. And the component along y direction, this is x direction. This is uy, that's equals to u sin theta. And g cos alpha is perpendicular to plane. This is also perpendicular to plane, so acceleration in y direction is g cos alpha. And along this direction, acceleration is along x dash, that is equals to g sin alpha c. When the body was projected in upward direction, motion was retarded, but here motion is accelerated because acceleration is along the direction of ux, and finally the body strikes on the plane at this point. In similar way, this is maximum height. Time of flight same. 2u sin theta by g cos alpha. You just put this formula here also. In similar way, you can derive maximum height is same, but what about r? These two are same. What about range? This is range, total distance in x direction. S is equal to ut, ux into time of flight is t. Acceleration is along the direction of velocity plus half ax dash into t square. Only difference here minus, here plus. Here minus, here plus. So, range is equal to u cos theta into t plus half. Acceleration is, g sin alpha. G sin alpha. Acceleration is g sin alpha into t square. Up the plane, you may use this formula. Down the plane, just use this formula, or in accordance with this formula, you can derive it. Just keep it in mind. 2u square by g sin theta into cos. This is theta plus alpha. Here positive will come, means theta minus alpha. And condition for maximum range. Condition for maximum range, here theta is equal to pi by 4 minus alpha by 2, here pi by 4 plus alpha by 2. And again maximum range, what will be formula for maximum range? It is down the plane. It is down the plane, just put here minus. U square divided by g into 1 minus sin alpha, this much, down the plane. But concepts are same. Is it clear? Okay. Then go to some numericals, some 1 or 2 numericals, basic numericals. Okay. Will I erase all this? Go through it once, all the derivations, and keep this way of derivation in your mind, and just use this formula. Nothing is difficult. Okay. I'm erasing all this. Fundamental question, basic question. Question number 1. A body is projected at an angle of 45 degrees from the surface of an inclined plane of angle of inclination (37°) with horizontal with a velocity of 10 root 2 meter per second. This much. A body is projected at an angle 45 degrees from the surface of an inclined plane of angle of inclination 30 degrees. This is the inclined plane. Angle of inclination is alpha, that is 37 degrees. A body is projected from the surface of an inclined plane. U is equal to 10 root 2 meter per second at an angle 45 degrees with inclined. Okay, with inclined plane. Then you may find what is time period, what is horizontal range, what is maximum height. Just put this formula. Okay. Then time of flight. I will not calculate. You will calculate. Then T is equal to 2u sin theta by g cos alpha. So this is theta. Theta is 45. Just use this. U is given. Theta is 45. Sin 45 is 1 by root 2. Means 2 into 10 root into 1 by root 2 divided by g. Let's take 10 into cos alpha. Alpha is 37. So this is 3, this is 4, this is 5. This angle is 90. Then cos 37. Cos 37 is base upon hypotenuse 4 by 5. This much second. Just calculate it. I do not calculate. Then what is maximum height? Maximum height is u square sin square theta divided by 2g cos alpha. You can do it now. Then for range, AC is equal to ux t minus half. Acceleration is in this direction, means g sin alpha. Minus half. Acceleration is minus g sin alpha. This is plus, this is minus half a t square. You have calculated t. Time period, put here, and ux is u cos theta. Into t minus half g sin alpha into t square. So this is alpha. Alpha is 37. Cos alpha is 4 by 5. Sin alpha is, this is alpha. Sin alpha is 3 by 5. Put all these values. Value of u, theta, time period we have calculated. Put all these values and get range. Then you may apply condition for maximum range, condition for maximum height, whatever we asked. Okay. The next question, good question also. Question number 2. Okay. Find angle of projection of a body projected from an incline from the surface, of an inclined plane of angle of inclination 45 degrees, so that it strikes. We have to find angle of projection so that it hits the surface horizontally. Very easy question. Just see the concept. This is the inclined plane, and angle of inclination is 45 degrees, means alpha is 45. Angle of inclination is 45 degrees. Body is projected with a velocity u, making an angle theta with the inclined plane. So theta is asked. Find angle of projection, and the body moves like this and finally strikes the surface. Like this. Oh. Strike the surface like this. This is horizontal direction. Parallel to x-axis. This is horizontal. Okay. body strikes like this. Okay. Then body strikes with final velocity v. This is x component of velocity. This is y component of velocity in y direction. Then Vy is 0. This is y axis, this is x axis. Then component along y axis is 0 because final velocity is along x axis, means horizontal. But it strikes the surface horizontally. So Vy is 0. See, this component is u cos theta, ux dash, ux dash. This component is uy dash, that is equals to u sin theta. Okay. So let's consider, we will not take this because horizontal direction we have taken along x axis and vertical direction along y axis, so we don't need it. So component of u along horizontal direction means first assumption considering projection angle with horizontal. Projection angle with horizontal is theta plus alpha. Theta plus alpha. If this is velocity u, then total angle with horizontal is theta plus alpha. Then component along horizontal ux, that x dash, is u cos theta plus alpha. And component of u in vertical direction, means in y direction, is uy, that is u sin theta plus alpha. So this is u, this total angle is theta plus alpha, this is ux, u cos theta plus alpha, this is uy, u sin theta plus alpha. Then final vertical velocity is 0 and uy is opposed by acceleration due to gravity. Uy is in vertically upward direction, acceleration due to gravity is in vertical downward direction. So motion is retarded initially, thereafter it will increase. Okay, as we have discussed in the first lecture. Okay, then V is equal to uy plus at. This is acceleration in y direction plus ay into t, time of flight is t. Then Vy is 0, uy is u sin theta plus alpha. Acceleration is opposite, velocity is upward, acceleration is downward, means minus g into time of flight is t. Time of flight is t. Then gt is equal to u sin theta plus alpha and t is equal to u sin theta plus alpha whole divided by g. This is time period we got here. But actually, we know for inclined projection, time period is 2u sin theta divided by g cos alpha. We have derived this. Then this is formula for time period, this is also formula for time period. Equating these two, this is equation 1 and this is equation. Equating equations 1 and 2, you may equate these two equations, then what you will get? U sin theta plus alpha whole divided by g is equal to 2u sin theta divided by g cos alpha. Just equate these two equations. Then g get cancelled, u again get cancelled. Now solve. This is sin theta plus alpha. Okay, angle of inclination is alpha is 45 degree. U sin theta plus alpha. Okay. Then just open it. No, I am writing again. Sin theta plus alpha is equal to sin theta by cos alpha. Okay. Sin theta plus alpha, sin theta into cos alpha plus cos theta into sin alpha is equal to sin theta divided by cos alpha. So here alpha is 45 degree. It is given. Then sin theta cos alpha cos 45 is 1 by root. Then cos theta sin alpha alpha is 45 sin 45 is 1 by root. Then sin theta divided by cos alpha alpha is 45 means divided by 1 by root. So 1 by root to bring it common sin theta plus cos theta, and this is equals to root 2 2 sin theta, sorry, 2 sin theta, this is 2, this is 2, so this is, so cross multiplied 1 by 2 root 2 into root 2 means 1 by 4. 2 into root 2 into root 2 is 4, 1 by 4 sin theta plus cos theta is equal to sin theta. So sin theta plus cos theta is equal to 4 cross multiplied 4 sin theta, then 4 sin theta minus sin theta. 4 sin theta minus sin theta is cos theta, means 3 sin theta is equal to cos theta. Then sin theta by cos theta is equal to 1 by 3. Sin theta by cos theta is 1 by 3. So tan theta is 1 by 3, and finally theta is equal to tan inverse 1 by 3. This is your answer. This is your answer. Okay. So angle of projection should be tan inverse 1 by 3 if alpha is 45 degree. So alpha may be given any other value. So we have to solve it. Okay. Then last question. Question number 3. Question number 3. Find relation between angle of inclination and angle of projection. Find relation between angle of inclination and angle of projection so that a projectile fired from the surface of an inclined plane hits the surface. Projectile fired from the surface of an inclined plane hits the surface perpendicular perpendicularly. Just see the situation, it is easier. This is angle of inclination alpha. Body is projected with velocity u with angle of projection theta, and the body moves like this and strikes on the surface at an angle 90 degree perpendicularly. Okay. Then as we have taken, consider this is x direction and this is y direction, x dash y dash. Okay. Then component of velocity along x direction is u cos theta, and component of velocity in y direction is u sin theta, and this is opposed by g cos alpha, and this is opposed by g sin alpha. See, the body strikes at an angle 90 degree, means this component is Vy dash. This is perpendicular. This is also perpendicular. So Vy dash, body strikes the surface perpendicularly. So this component is Vy dash. Then along this direction Vx dash is 0. Vx dash is 0 because this velocity has no component in x dash direction, means both are perpendicular to each other. So final velocity in x direction is 0. Initial velocity in x direction, acceleration in x direction is equal to minus g sin alpha. Initial velocity in x direction is u cos theta. Final velocity in x direction is 0. And time of flight is t. Okay, again the same way, find the formula for time of flight. Okay, then v is equal to u plus at. Then final velocity is 0. Ux dash is u cos theta minus acceleration is minus opposite g sin alpha into t. So t is equal to u cos theta divided by g sin alpha. This is formula for time period also. This is equation 1. We got value of time period 2u sin theta by g cos alpha. We know this formula. 2u sin theta by g cos alpha. Take this equation 2. Now equating equations 1 and 2, t and t are equal. Then equating this 2u sin theta divided by g cos alpha is equal to right side u cos theta divided by g sin alpha. U g get cancelled. Okay, then this is 2 sin theta divided by cos alpha. 2 sin theta divided by cos alpha is equal to cos theta divided by sin alpha. Then sin theta divided by cos theta, sin theta by cos theta is equal to 1 by 2 cross multiply 2 and cross multiply cos alpha, half into cos alpha divided by sin alpha. Then this is tan theta. This is 1 by 2 cos alpha by sin alpha is cot alpha. Then tan theta is equal to 1 by 2 into cot alpha is 1 by tan alpha. Then product of tan theta and tan alpha is equal to 1 by 2. This is the required condition. Means a relation between angle of inclination alpha and angle of projection theta, means product of tangent of angle of inclination and tangent of angle of projection is equal to 1 by 2, so that the body strikes the surface normally. Okay, is it clear? And you follow objective, you follow your reference book, you will get some more questions. Okay, thanks my children, thanks.